Systems and system models is the fourth cross-cutting concept for the K-12 Science Framework for Education. This presentation will teach about the concept and how to integrate NAEP questions into lessons to teach the cross-cutting concepts. The fourth cross-cutting concept focuses on examining and defining what is and what is not part of a system or model as a tool for examining scientific ideas. Defining the system under study, specifying its boundaries, and making explicit a model of that system provides tools for understanding and testing ideas that are applicable throughout science and engineering. Approaching science from a systems point of view allows us to take a step back and consider the boundaries of different systems. Are they flexible or inflexible? Components and relationships between components of a system help us to understand the inner workings of a system. The units of investigations can be referred to as systems. A system is an organized group of related objects or components to form a whole. Systems can consist, for example, of organisms, machines, fundamental particles, galaxies, ideas, and numbers. Systems have boundaries, components, resources, flow, and feedback. When using models as teaching tools, we must teach students to be critical thinkers who can be aware of what assumptions and decisions were made in creating models. Any model of a system incorporates assumptions and approximations. The key is to be aware of what they are and how they affect the model's reliability and precision. A good system model for use in developing scientific explanations or engineering designs must specify not only the parts or subsystems of the system, but also how they interact with one another. It must also specify the boundary of the system being modeled, delineating what is included in the model and what is to be treated as external. National Assessment of Educational Progress, or NAEP, is used around the country to determine how states are doing compared to other schools in particular content areas. This is done through online testing. NAEP has released practice questions for teachers to use as they see fit. NAEP questions are useful to use in lessons and assessments to help students get comfortable with the format and learn strategies to advance their own learning. The Next Generation Science Standards, which use the K-12 framework as a guide, developed a concept progression for different grades. They aligned some content standards or core ideas with the cross-cutting concepts. The developers of the NGSS did not identify a performance standard that aligns with the standards. However, the following two slides identify two NAEP items that do fit with standards in the K-12 Science Framework for Education. Teachers may find other NAEP items that also help teach and assess the K-12 framework. Released NAEP items in this presentation are aligned with one grade band, but many of them could fit with different grade bands to meet the standards. We had to pick one, but be creative. The NAEP symbol on each question page is a link to the original NAEP question on the NAEP website. The NAEP website includes useful information such as difficulty rating, to which grades it was administered, percentage of students who answered the question correctly, and the answer key. In the figure above, which of the following is the pathway of light that allows the child to see the ball? A, B, C, or D? Teachers may use this as part of a unit assessment, individual or partner work, or as part of a class discussion. This question asks students to determine the path of light, but the path is not included in the diagram. This could lend itself to some in-class experiments with lasers, flashlights, mirrors, or other available materials. Can you design an experiment to test this? How could the picture be modified to include the path of light? Is there more than one correct answer to this problem? How do you know? Raphael and Sammy were playing with soccer balls on a flat tile floor. Each boy rolled a soccer ball at the same time, and the balls hit, as shown below. Which boy rolled his ball faster? How do you know? Diagrams work well as models in that they are a great way to visually represent phenomena. Teachers can lead discussions about the purpose of models, and that they often do not include every aspect of a system. Something is always assumed. How could we add the push forces to this model to make it more complete? How could we add the size of the force to the model to help someone else understand it? What information does the model already include to help you understand the relative sizes of the push forces? In grades 3 through 5, students understand that a system is a group of related parts that make up a whole and can carry out functions its individual parts cannot. Make a claim about the merit of a solution to a problem caused when the environment changes and the types of plants and animals that live there may change. Students in grades 3 through 5 focus on understanding that systems are made up of many different parts that work together. This NAEP item requires identifying different organisms from the food web that fit certain categories. Food webs are made up of different food chains. This is one example of a model being composed of smaller components that could also be subdivided into individual organisms. How many different relationships make up a food web? What different types of relationships make up a healthy food web? How could the relationships between organisms be sorted? What parts of a habitat are not included in this diagram? What roles do they fulfill? Is all the energy in the system accounted for? Mercury is the planet closest to the Sun. In the box below, draw a diagram showing each of the following. Label all parts of your diagram: Earth, Mercury, Sun, orbits. This NAEP item requires students to create their own simplified model of the solar system using the listed components. Before students begin, they need to consider what else needs to be included that was not listed. One example is the scale of the model. Is it necessary to show scale? If so, how will you do it? How will you show any relationship between Earth, Mercury, Sun, and orbits? In grades 6 through 8, students can understand that systems may interact with other systems. They may have subsystems and be part of larger complex systems. They can use models to represent systems and their interactions, such as inputs, processes and outputs, and energy, matter, and information within systems. They can also learn that models are limited in that they only represent certain aspects of the system under study. Construct and present arguments using evidence to support the claim that gravitational interactions are attractive and depend on the masses of interacting objects. The big ideas here are systems and subsystems, processes within systems such as input and output, and limitations of systems. In the diagram, which portion of the carbon cycle is driven directly by Earth's internal heat energy? The movement of carbon between the ocean and the atmosphere. B, the emission of carbon dioxide from oil-burning power plants. C, the release of carbon dioxide during volcanic eruptions. Or D, the exhalation of carbon dioxide by animals. This NAEP item asks students to identify the relationship between the carbon cycle and the geosphere. The relationship is not clearly stated in the model, so students need to be able to determine the boundary of the model. What is truly within the model and what may affect the model? In a simplified model of the solar system, the planets revolve around the Sun in circular orbits, all in the same plane. Each planet has a different period of revolution. Also, each planet is a sphere that rotates about an axis through its center, but with a different period of rotation. In this model, the axis of rotation of each planet is perpendicular to the plane of the orbit. What extension or modifications could be made to the simplified model of the solar system to explain why the northern hemisphere is colder in January than in July? You may draw a diagram as part of your answer. Students are required to draw a model of the solar system that includes planets, the Sun, revolution around the Sun, and rotation about an axis. Then they are asked to modify the model as needed to help explain seasonal temperature changes. Teachers may begin by prompting students with some of the following questions. Do we need to change the boundary of our current model? Why or why not? What additional components do you think should be included within the established boundary of our model? Are there any parts of the model that are not necessary that could be taken out? The new models may then be tested and redesigned by trading with other students. In grades 9 through 12, students can investigate or analyze a system by defining its boundaries and initial conditions, as well as its inputs and outputs. They can use models, physical, mathematical, computer models, to simulate the flow of energy, matter, and interactions within and between systems at different scales. They can also use models and simulations to predict the behavior of a system, and recognize that these predictions have limited precision and reliability due to the assumptions and approximations inherent in the models. They can also design systems to do specific tasks. Develop a model to illustrate the role of photosynthesis and cellular respiration in the cycling of carbon among the biosphere, atmosphere, hydrosphere, and geosphere. Big differences in high school for cross-cutting concept number 4, addition of math, computer modeling, use of models to make predictions, use of models to complete tasks, and examination of the reliability of models. In a simplified model of the solar system, the planets revolve around the Sun in circular orbits, all in the same plane. Each planet has a different period of revolution. Also, each planet is a sphere that rotates about an axis through its center, but with a different period of rotation. In this model, the axis of rotation of each planet is perpendicular to the plane of the orbit. One early simple model of the atom is very similar to the model of the solar system described above. Draw a sketch of this simple model of an atom, labeling its components. This problem uses the same base model as the model used to demonstrate the seasons in the previous grade band. This is but one example of how NAEP items can be used in a variety of ways to address different content standards, cross-cutting concepts, and science and engineering practices at different grade levels. High school students are asked to adapt a basic model of the solar system to create a model of the atom. What are some similar components of the two models? Which components might you pair together from the solar system to the atom? Are there any subsystems that need to be included, excluded? How does comparing two models of two different ideas help you to understand either one better? Are there any aspects of the models you have questions about after working with the two models? Scientists are studying the evolutionary history of a group of plants in the United States, and they develop an evolutionary tree, as shown below. Which statement can be inferred from the evolutionary tree? A, B, C, or D? The NAEP item deals with reading relationships along an evolutionary tree model. How are relationships shown on this model? Have you seen this type of model used to show other relationships? Do you think this type of model is accurate? Why or why not? What did the designer of this model assume about the evolutionary tree and or someone who might use it? How does that help you to determine whether this model is accurate or not? 2 resources for teachers to get other perspectives on cross-cutting concept number 4, systems and system models. NSTA also has a variety of digital and print resources and trainings available to educators that are grade level specific.